Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this part 10 video from the chapter of Heron's formula, I will discuss about how to find the area and perimeter of a quadrilateral in general, where of a quadrilateral that is the quadrilateral is not a trapezium or it is not a rhombus. It is in general a quadrilateral, and in the next video I will discuss about the area and perimeter of a trapezium. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so how do we find the area of a quadrilateral? There are basically two methods to find the area of a quadrilateral where it is not a trapezium or it is not a rectangle, square or rhombus. So in the first case, first method is that if we know the length of a diagonal, consider the figure 1, if we know the length of a diagonal, say AC, let's say the length of the diagonal AC be D, and also if we know the length of the perpendiculars drawn on this diagonal AC from the opposite vertices B and D, let's say the perpendicular BO, length of the perpendicular BO be H1 and the length of the perpendicular PD be H2, then also we can find the area of the quadrilateral. Now similarly, the length of the diagonal considered could be BD, and if we know the length, consider the figure 2. In figure 2 we know the length of the diagonal BD, let's say the length be small d, and we know the length of the perpendiculars drawn from the opposite vertices on the diagonal BD. The opposite vertices to the diagonal BD are A and C, and AO and CP are perpendicular to the diagonal BD. Okay, so in this method, what will be the area of the quadrilateral? So for first and second case, where we know the length of a diagonal and the length of the perpendiculars drawn from the opposite vertices on the diagonal, then we can find the area. Now okay, so what will be the area in this case? Consider the figure 1. It will be same for the concept, it will be same for figure 2. We see that we know the diagonal AC in figure 1 is dividing the entire quadrilateral into two triangles ABC and ADC. So we can say area of the quadrilateral ABCD will be equal to the sum of the area of the triangle ABC plus area of the triangle ABC and triangle ACD. Now what is the area of the triangle ABC? We know BO is perpendicular because AC is a side and BO is the corresponding altitude. So the area of triangle ABC will be half into BO into AC. Similarly, the area of the triangle ADC will be half, since PD is the altitude of the triangle and the base is AC, it will be half PD into AC. If I take AC by 2 common, I have BO plus PD. So this is AC is D by 2 and BO is H1 and PD is H2. So essentially we need, if we know the length of a diagonal and the sum of the length of the perpendiculars drawn on this diagonal from the opposite vertices, which is H1 plus H2, then the area will be D by half of the product of the length of the diagonal and the sum of the perpendiculars drawn on that diagonal from the opposite vertices. If we need not know individually the values of H1 and H2, even if we know the value of the sum of the perpendiculars, that is H1 plus H2, we can find the area. Okay, the second method is that suppose we know the length of all the sides of the quadrilateral and the length of one diagonal, any diagonal. We know that in a quadrilateral there are two diagonals. Consider the figure 4. We have the diagonal BD. Let's say the length of the diagonal BD is E, and the length of the sides AB, BC, CD and AD are A, B, C, D. How can we find the area of this quadrilateral from this given information? We will use Heron's formula. Clearly, area of the quadrilateral ABCD is equal to area of the triangle ABD, plus area of the triangle BCD. Now, we know the length of all the sides of the triangle ABD, which are AD and E, and we also know the length of all the sides of the triangle BCD, which are B, C and E. So, clearly we can find, using Heron's formula, we can find the area of these two triangles, and then we can find the area. We will sum the two areas, which will be the area of the quadrilateral. So, this is the basic concept. Okay, so let's say what will be the area of triangle ABD using Heron's formula? It will be square root of, let's say I am calling the semi perimeter of the triangle ABD as S1. So, it will be S1 multiplied by S1 minus A, S1 minus D, and it will be S1 minus E. Okay, where S1, the semi perimeter, is equal to A plus D plus E by 2. Also, then the area of the triangle BCD will be equal to square root of, using Heron's formula. Let's say the semi perimeter of the triangle BCD is S2. So, it will be S2 multiplied by S2 minus B multiplied by S2 minus C multiplied by S2 minus E, where S2, the semi perimeter of the triangle BCD, will be B plus C plus E by 2. So, this way, applying the Heron's formula, we can individually find the area of the two triangles which is formed by the diagonal BD. Now, it could be also the diagonal AC. It will be the same concept. So, if we are given the length of all the sides of a quadrilateral and the length of one diagonal, then using this concept we can find the area. So, these are the two methods using which we can find the area of a quadrilateral, which is not a rectangle or square or rhombus or trapezium. So, that is all for this video. I am not going to solve any problem. In the next video, I will discuss about how to find the area. Obviously, to the perimeter of a quadrilateral, we need to know all the length of all the sides of the quadrilateral. So, if the length of the sides of the quadrilateral are ABCD, then obviously the perimeter will be A plus B plus C plus D. In the next video, I will discuss about area and perimeter of trapezium, different types of trapezium. So, please stay tuned. I am ending the video here. Thanks for watching, and until the next video, take care and bye.